So, good day, viewers. Welcome to another mathematics presentation. So, in this presentation, we are looking at the topic index notation. So, index notation is a topic that you have been learning since 8th grade. Okay. So, index notation or indices or exponents, we are simply looking at a shorthand notation for multiplying the same number by itself several times. Okay. So for example, you can be multiplying 5 by itself 100 times, which can be written as 5 to the power 100. You are multiplying 5 by itself 100 times. So this is what we call index notation. Okay. So this 5 is called the base. Then this 100 right here is called the exponent. Okay. So these are some of the things that you must know. Okay. So here when you look at index notation, we are going to look at problem solving, how we can multiply indices and how we can divide indices. Okay, how we can work out with indices that are having negative powers, how we can work out with indices that have got the power which is raised to another power. We are also going to look at indices that have a power of a fraction. Then we also look at zero indices. So in short, these that I've said, we are normally going to look at the laws of indices. So it's very important that you understand. So here, first thing, we are going to look at laws of indices. So under the laws of indices, it's very important that you know these laws, because they can ask you to use them, okay, in terms of simplifying or solving indices or evaluating indices. So the first law that we are going to look at is a law that talks about multiplication of indices. Okay, so this is our first law, the law that talks about multiplication of indices. Now, under this law, there are certain things that you must know. When you multiply indices that have the same bases, okay? For example, we have a to the power m times a to the power n. So you can see that the base here is a, again the base here is a. So this one can be simplified by, since the two bases are the same, we are multiplying indices that have the same bases. We can write the base that is common. Then these powers, we are going to add them. So we write m plus n. So this will mean it is our answer. We have simplified. Okay. So in terms of the number, let's say we have 2 to the power 2 times 3 to the power 4. Okay, so let me just write here. We have 2 to the power 4. So since we are multiplying indices that have the same bases, we will get the same base, which is a 2. Then we are going to add the power, this power 2 plus this power 4. So we are going to have 2 plus 4. And this is going to give us 2. So 2 plus 4, it will be 6. We have simplified. So we are going to have our answer as 2 to the power 6. Now, in case they say, can you evaluate? Okay. But if they say simplify, you can leave your answer at this stage. But if they say evaluate, you can proceed by, remember what I said, 2 to the power 6 means you multiply the base 2 by itself 6 times. So I'm going to say 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. This gives us, so 2 times 2, it's a 4. 4 times 2, it's 8. 8 times 2, it's 16. 16 times 2, it's 32. 32 times 2, so gives us 64. So if you are asked to evaluate, the answer is going to be a 64. So this is under the first what? The first law. So you must know these things. So apart from this example 1 and example 2, you can also be given another example which can be written in this form. You can have maybe 3 to the power 4 times 3. So here the base that is common is a 3. So we write 3, its power it's a 4, 4 plus. Now, if they just write a number like this without anything on top, it means that number is having a power of what? 1. So it will be 4 plus 1. So again, let's say if I give you 10 to the power 4 times 10. So this means you get the same base 10, then you say 4 plus. So I'm saying this 10 doesn't have any power, so it's having a power of 1. So 4 plus 1. And this will give us 10 to the power 5. That's the same principle we are using it. So we are just going to say 3 to the power 5. This is our answer. If the question is just saying simplify. But if it's saying can you evaluate, you will say 3 times 3 times 3 times 3. Okay, again times 3. You multiply 3 by itself 5 times. 1, 2, 3, 4, 5. So when you do that, you are going to have 3 times 3, 9, 3 times 3, 9. So 9 times 9, 81. So we have 81 times 3. 81 times 3, which gives us 3 times 1 is a 3, 3 times 8 is a 24. So this will give us 243. If they say evaluate, but if they just say simplify, leave your answer at this stage. Okay, so I hope you have gotten something there. Apart from that, there are many examples that we can have. There are many examples that you can have under the first example. So let's say we have our fourth example there under the first law. When they say if you have 5, okay, 5 that is raised to the power of 5 times 5 raised to the power of 4. So the common base is a 5. So I'm just going to say 5 plus 4. We add the powers. So this will be 5 to the power 9. Okay? 5 to the power 9. So this is our answer. Then if you have your fifth example where they have said maybe 7 to the power 3 times 7 to the power 2. You just get the common base 7. Then you say 3 plus 2. This will give us 7 to the power of 5. This is our answer. So I'm sure under the first law it's clear. We now move on to our second law. So under our law number 2, so under law number 2, we are looking at the division of indices. So this one is for division of indices. Now, when it comes to dividing of indices, okay, for example, if you have a to the power m divided by a to the power n, so this can also be written as a power m over a power n, like this. You can use this division sign, or you can use this one in a fraction form. Any form of division you can use. Now, when you divide indices that have the same bases, okay, or that have the same bases, so you can see that here the base is a 4, sorry, a, here the base is a. You write the common base a, then what do you do to the powers? You subtract them, so you have m minus n. Okay, and this will be our answer, because m minus n we can subtract, those are just letters. I'm just using them for demonstration purposes. Now let us look at another example using the numbers. So here, if you have 5 raised to the power of 4 divided by 5 raised to the power of 2. So since we are dividing indices that have the same bases 5, same base 5, you write the base 5, then you say 4 minus a 2. We are going to subtract the what? The powers, because we are dividing indices with the same bases. So we are going to have 5 to the power 2. This is our answer. Now, if they just say simplify, you end right here. But if they said evaluate, you are going to evaluate 5 to the power 2, which means 5 times 5, which is equal to what? 25. Not 5 times 2, not 5 times 2. Okay? This is wrong. Don't do this. Okay? So, I hope it's clear. We can look at another example. So, let's look at another example. We are on example 3. We have 4. Okay, we have 4 to the power 9 divided by 4 to the power 3. So this will mean 4 to the power 9 minus 3. Same bases, the base 4, the base 4. So we subtract the powers if you are dividing inside the same bases. So we are going to have 4 to the power 6, because 9 minus 3 gives us a 6. So we are going to have 4 to the power 6 as our answer. So we now move on to our fourth example under division of indices. So let's say we have something like 3 to the power 3, okay, divided by 3. So this 3, remember what I said? If there's nothing on top of this 3, it means it has a power of 1. So just get the common base 3, then you say 3 minus 1. So this will give us 3 to the power 2. This will be our answer. So 3 to the power 2 means you multiply the base 3 by itself. 2 times 3 times 3 gives us what? 9. Okay? So I hope it's clear here. Those are the examples. Those are the examples that we can have under division of indices. So let's now move on to our law number 3, which is law 3. So under the third law, okay, we are going to look at negative indices. We are going to look at negative indices. So remember when I was teaching, we just ended on the second law. So under this law number 3, we are looking at the negative indices. So if A is a base and M is a negative power, if A is a base and M is a negative power, you can write this as okay. So don't write indices, don't write your answer in index form having the power with a negative. No, you have to make sure that your power is always a positive. So the way you can write this, you can say 1 over A power M. So you can see the negative has gone from M. That's why we have written a 1 right here. Okay? Now let us try to look at another example apart from this one. So if you have something like this, if you have maybe 6 raised to the power of negative 2, you can write this as 1 over 6 power 2. You can now evaluate, you say 1 over 6 power 2 means 6 times 6 to give us 1 over 6 times 6, 36. So here we are just applying what we know. 6 power 2 means we multiply the base 6 by itself 2 times. Okay? Let us look at another example. So if you feel that you are behind, you can leave a comment in the comment section. I'll be able to get back to. So if you have 8 raised to the power of negative 1, okay, this will give us. So since we want to get rid of this negative, we are going to write 1 over 8 raised to the power of 1. So any number raised to the power of 1 will get the same number. So this will be 1 over 8, like this. So take note, even if you have 100 to the power of 1 to give you 100, even if you have 14 to the power of 1, you still get what? 14. Even if you have 201 to the power of 1, you still get 201. So you must note that any number raised to the power of 1, you get the same number. Okay? This is very important. That's why here we had 8 to the power of 1. We have gotten 8 right here. So I hope these examples are clear. Okay, I hope they are clear. We can just try to look at uh, the second example. So let's say you have let's say you have something like this. Make sure you take note of this example. Let's say you have something like 4 power 3 divided by 4 power 5. So here, because we are dividing indices that have the same base 4, the base 4, we are going to write 4. Then what did we say? We said if you are dividing indices that have the same bases, you subtract the powers. So the power there we have a 3 minus 5. So here we are going to have 4. Now 3 minus 5. The smaller number is subtracting a bigger number. So our answer will be a negative 2. So you can't leave this as your answer, okay? You still need now to combine with the other law, okay? Because we're having a negative here as a power. So we are going to have 1 over 4 to the power 2. If it's just to simplify, this will be your answer. But if it's to evaluate, you are going to have 1 over 4 to the power 2 means you multiply the base 4 by itself twice, which is 4 times 4. And you are going to have 1 over 4 times 4, you are going to get a 16. So this will be the answer. Okay? So I hope it's clear. We now move on to our fourth row. This was our third row. So we now come to our fourth row. So law number 4. So law number 4, we are going to look at the power raised to a power. Okay? A power that is raised to another power. What does this mean? This means that if A is a base, okay? If A is a base, for example, you have A as your base, okay? And M and N are powers. So this A is raised to the power of M. Again, you put it in brackets. The same is going to be raised to the power of what? N. This is what we call power raised to another power. A raised to the power of M. Again, the same index is being raised to the power of what? N. So how do you work out this one? Okay, so to work out this one, what we normally do is we write A, the common base, then we're going to multiply this M times N. That is how we deal with indices where a power is raised to another power. So we're going to have M times N, and we are going to get our answer as A power M N. So that is how we can simplify that. In terms of the numbers, let's say you have something like this. You have 4 raised to the power of 2 over 2. So 4, the power is a 2, which is in brackets, times the power which is outside here, 2. So this will be 4 raised to the power of what? 4, because 2 times 2 is a 4. This will be your answer, if just to simplify. Okay? Then you can also look at another example. So let's say you have this example 3. Now this 3 will be raised to the power of 3. Brackets. Again, we raise it to the power negative 2. Excuse me. So how do you solve this one? So here what we are going to do is we are going to do the same. We will say 3 times negative 2. We'll get the power 3 times the power which is the negative 2. And this will give us 3 to the power negative 6. Now remember, we can't leave our answer like this. Okay? Why? Because of the negative which is on the power. So we are going to rewrite this as 1 over 3 to the power 6. Now you can leave your answer like that. Okay? If it's to simplify, you say 1 over, you multiply 3 by itself 6 times, which is 3 times 3 times 3 times 3 times 3 times 3, 1, 2, 3, 4, 5, 6. You are going to get something like 729. So this will be 1 over 729. If it's to evaluate, if they say evaluate, but if they just say simplify, you just simplify your answer to this stage only. So I hope this law is clear. Okay, I hope this law is clear. We now come to another law, which is our fifth law, law number 5. We've now come to our law number 5. So this law number 5 just talks about power of a product. Okay, that is law number 5. So I've said law number 5 talks about power of a product. Power of a product. So I want you to follow me nicely. What does this mean? This means that if A and B, okay, if A and B are bases, if you have the base A, then you have the base B. If A and B, both of them are bases, and the product of A, meaning A times B, this can also be, or it can also be written as A times B. Both of them are bases, or the product of A times B is raised to the power of n. So this one is raised to the power of n, or this one is raised to the power of n. So this and this is one and the same. Okay, so if you have something like this, this is what you are calling power of a product. So this one, the way you can do it, this n is affecting A and is affecting B. So it will be A power n times B power n. Okay, that is how you can rewrite it. Okay, now let's look at it in terms of the numbers. Let's look at it in terms of the numbers. So what of if you have 2 times 3 raised to the power of 2. 2 times 3 raised to the power of 2. So I've said since 2 is a base and 3 is a base, and it's the product of 2 and 3 raised to the power of 2. It means the power 2 is affecting these 2 inside the brackets and these 3. So this will be written as 2 power 2 times 3 power 2. Okay, so here the bases are different, so you can't apply n law, but what you do is you just say 2 times 2, that's what it means, 2 raised to the power of 2. You multiply this same base by itself twice, times 3 power 2 means 3 times 3. So this will give us 2 times 2 will get 4, times 3 times 3 will get 9. So once we multiply these two, 4 times 9, we're going to get 36. So this will be our answer. So I hope it's clear there. So we look at another example. So what if you have, this is our third example. If you have 3 power x, 3x raised to the power of 3, sorry. So this one, remember what I've said, the power is affecting both numbers that are inside the brackets, both bases. So what you are going to do here, you just separate, you say 3 power 3 times x power 3. Okay, that is what you are going to do. Now 3 power 3 means you multiply the base 3 by itself 3 times, which will be 3 times 3 times 3, then times x power 3. This one is it's a letter, so you can't simplify it further. So 3 times 3 times 3, this gives us 27. Okay, 27 times x power 3, and this gives us 27 x power 3. This is our answer. Okay, I hope you are following. Okay, so we look at the last example under this law. The last example under this law that we can look at is if you have 4ab raised to the power of what? 2. So I've said this means the power is affecting all the bases that are inside the brackets. So this will be 4 power 2 times A power 2 times B power 2. Okay, so 4 power 2 means 4 times 4, okay, which will give us what? 16. Okay, 16 times A squared times B squared. So the final answer it will be 16A squared B squared. This will be our final answer. I hope it's clear. If you have any question, you are free to leave a comment in the comment section in the group. I'll be able to respond back to you. So let's say we now come to our law number 6. Law number 6, we are looking at the power of a fraction. Power of a fraction. This is law number 6. Power of a fraction. Now, power of a fraction. What does this mean? Okay, if you have a and b are the bases, and the fraction of a and b is raised to the power a over b. Okay, you have seen these are the bases. It's a fraction. Now, this same a over b will be raised to the power n. Okay, this means that this n is affecting a, so a power n over b power n. So n is affecting the numerator, it's also affecting the denominator. Okay, this is what we call power of a fraction. Another example that we can look at. Okay, let's say you have 2 over 3 in brackets. So this is your fraction that will be raised to the power of 3. So this means that 2, which is the numerator, is going to have the power of 3, and this 3, which is the denominator, is also going to have the power of what? Of 3. So you are going to have 2 power 3 over 3 power 3, which will be 2 power 3 means 2 times 2 times 2 times 2. You multiply the base 2 by itself 3 times. Okay, that's 2 power 3. Again, 3 power 3 means 3 times 3 times 3. You multiply the base by itself 3 times. So 2 times 2, it's a 4. 4 times 2, it's 8 over 27. Because 3 times 3, you are going to get you get a 9. Again, 9 times 3, you're going to get a 27. So this will be your answer. Okay, let us now look at another example. So let's say you have this other example where you have x over 3 to the power 2. So x over 3 to the power 2, we are just doing one and the same. You say x power 2 over 3 power 2. So x power 2 is just x power 2. 3 power 2 means 3 times 3, which will give us 9. So this is our answer. Okay, now let's look at our fourth example where we have maybe we have a over 4b. Okay, in brackets raised to the power of 2. So this means that 2 is affecting a, it's also affecting 4b down here. So this will be written as a power 2 over, remember here I've got 4 and a b, so the 4 will also be squared times the b will also be squared. So on top we are going to have a power 2 over 4 power 2 means 4 times 2, 4 times 4, sorry, which will be a 16, then times b squared. And this will give us our final answer as a squared over 16b squared as our answer. So I hope that it's clear. You have gotten something under law number 6. I believe this is law number 6. Okay, so I hope it's clear. Let us now look at our next law number 7. So we are on law number 7. So these laws are very important for it. 0 indices. 0 indices. Now if A is the base and n is equal to 0, meaning the power is equal to 0, A is the base and the power is 0, then we are going to have a 1. So this law states that any number that is raised to the power of 0, okay, the answer is a 1. Even if you have 100 to the power 0, the answer is 1. Even if you have 7 to the power 0, the answer is 1. Even if you have 4 to the power 0, the answer is 1. Of course, it's a different issue if you have 0 to the power 0. This one, the answer is undefined. Okay? So, for this one, we normally say the answer is undefined, 0 to the power 0. But if you have any number greater than 0, which is raised to the power of a 0, that should give you a 1. Okay? That's the interpretation of law number 7. So I hope this one is not complicated. Examples, if you have 9 power 0, the answer is 1. Again, if you have 2 power 0, the answer is also a 1. If you have maybe 49 power 0, the answer is a 1. Okay? Any number raised to the power of 0, it's equal to 1. Okay? That's the interpretation. Another example, you can have something like 8 power 3, okay, divided by 8 power 3. So same bases, 8, 8, and we are dividing. What do? You subtract the power. So 8 to the power 3 minus 3. This will give us 8 to the power 0 because 3 minus 3 is a 0. So 8 power 0, the answer is what? 1. We are using this same property. A number raised to the power of 0, the answer is a 1. Apart from that, you can also have another example, which can be 4 power negative 5 times 4 power 5. Okay, so here we are multiplying bases that have the same, we are multiplying indices that have the same bases. 4, 4. We'll get 4. The power here is a negative 5. Now, since we are multiplying, we are going to add plus this other power, which is a positive 5. So negative 5 plus 5, it will give us a 0. So it will be 4 power 0, which will be a 1. A 1. So these are some of the things that you must know. So the other law that is remaining, which is just a fraction or index, I'm just going to make a video, a separate video for this law so that you can go through. So first thing, go through these laws that I've given you. Then you can also try to work out some of the questions. So task, so for the task you say evaluate. Remember what I said about evaluate? Okay, evaluate the following. We are not simplifying, we are evaluating, meaning that we need to find the value. Evaluate the following. Okay, so the first one that I can give you is if you have something like the first one, let's just say number 1, you have 4 power 2 times 4 power, just like that. Number 2, if you have 6 power 7 divided by 6 power 5. You need to evaluate. Number 3, let's say you have 10 power 8, okay, times times 10, okay. Yeah, for such bigger numbers, you can even use a calculator. Okay, number 4, let's say you need to evaluate where you have 1 over 2 raised to the power of 3. Okay, so these are some of the questions that you need to answer. So we've come to the end of our lesson. Thank you so much for having time to view this content. This has been your presenter, Mr. Mlenga. Bye bye.